calibration curve. Calibration curve. This is just there for the reaction. It's not going to enter in the calculation. That's the only thing you have to do here. Now, initial concentration for the thiocyanate, we use the 0.5 milliliter, 0.5 milliliter times 0.002, and when you do multiply by 20, that's the number will come. 5 times 10 to the minus 5, 1.00 minus 4, 1.5, 2, and 2.5. Now, here's the thing I want you to understand. The final concentration of FeSCN plus 2, the complex. And I'm assuming here, and as I said in the initial, that because the concentration is here is so high, this is 0.0, this 0.2000, and this is 0.002. It's 100 times bigger, higher concentration than this. Assuming the reaction will go to completion, and this equals this at equilibrium. Okay, this equals this. So that actually, because I need those value here, so that's what you're gonna plot in your. So you will have FeSCN final is the same as the initial concentration of thiocyanate. This is the calibration curve. Once I got this data and I have the transmittance, like what we did in the light absorption versus concentration, convert it to the A. You will have A here, the absorbance. You need to have plot, draw a graph with the Excel. A versus C. Please, I saw some people in that back doing the reverse. A versus C, because that's what Beer's law said. A equals ABC. You're gonna get a linear graph. And there's a slope on that. The graph will look like this. We already done this. And then I'll look for the linear equation. Be sure to have the linear equation in your, so you will have, for example, for this one, this is not necessarily what you're gonna get, 1996.4x plus minus 0.0599. Okay? We need this information here for our equilibrium. So we finish our calibration, okay? We finish our calibration. The whole purpose of that graph, that's how you do it. Very simple. You already got the kind of data here. If you use 1 milliliter, use this data. And then you already measure the transmittance. You know how to convert it to absorbance. A equal 2.00 minus log percent transmittance. Convert that, and you will generate the graph. You cannot do anything in the equilibrium before you get your graph here. Okay, we good here? Calibration, good? You guys here, if you can take a picture, because I need to clean the table here.
Yeah, I'll take a picture.
You already took it?
No, I'm about to take it.
Take it right away. And then, so because I need to clean and move to the other side because everybody finished. You need those values. If you don't have them, at least you can ask yourself how those values where they came from. You understand the guys in the back there? Andy and okay. You finished? You took the picture?
Yeah, I took a picture. You good?
Good. Let me clean. And I just do one and let you finish the rest of it, okay? We're gonna go to the equilibrium.
Oh wait, no.
In the equilibrium, we're gonna apply I stable, okay? Equilibrium here. Equilibrium calculation. Okay, we have to use I stable. Initial. For first test tube, initial, change, equilibrium. And you help me with your data because I don't have those numbers. So initial concentration, we will go and look at 5 milliliters times 0.002 divided by 10, and this initial comes out 1.00 times 10 to the power minus 3. If it's not correct, tell me.
That's right.
Okay, now for the second one, we have 1 milliliter times 0.002 divided by 10, and that will be 2.00 times 10 to the power minus 4. Is that correct?
Yes.
Molar. Initially, before I mix those, I have 0 here. Right? There's nothing there. Now, what it changed? Reaction will take place, system in equilibrium, minus x of here, minus x of here, and will give me x of this. Okay? My equilibrium will be this minus x. This minus x, and my equilibrium. The whole calculation based on this x here. Where I'm gonna get x from? X comes from my curve. I already measured the absorbance here, right? I measure the transmittance for the equilibrium, convert to the A, and I go to this equation here, and I will say, okay, my transmittance for the first one was 90% or whatever, this is 0.35 or whatever the number it got here, or 0.00. I'm just gonna throw a number here, for example. It was 0.35 absorbs, for example. And you substitute and find X. Okay? Is this clear?
Yes.
Okay? After I do the math, X comes out 3 X. I will here use this curve here and substitute for actually the first one was absorbance was 0.00859, for example. Okay, now I'm gonna use this equation there, so 0.0859 equal 199.614 plus x minus 0.0. This number you can't use. You cannot use those numbers. They are somebody else's number. There, just fine. So after you do the math, x comes out 3.95 times 10 to the power minus 5. So x here, I will say x equal this number here. Okay, that's for the first one. Is this clear? As a whistle, no problem with it. Question, please ask me if you have a problem with this. I already, for every tested tube, we measure the transmittance. We convert it to the absorbance. And we go back and say, okay, what's my value x? That's where x comes from. So now, I know x equal 3. So my x equal 3.95 times 10 to the power minus 5. And I go back to my equilibrium, and I say here, my equilibrium data, 1.00 times 10 to the minus 3 minus 3.95 times 10 to the power minus 5. And I'll do the math. And here would be 2.00 times 10 to the power minus 4 minus this. And x here will be 3.95 times 10 to the power minus 5. I get all the number I need for part number 1. Okay, so then what you do, you go K equilibrium equal FESCN minus at plus 2 here at equilibrium over F3 at equilibrium times SCN minus at equilibrium, and I got those numbers here, and fine. we were gonna find equilibrium constant for 5 different test tubes. They should be the same number. However, as you know by now, or you've been working, anytime you do experiment, there's error, so many factors from here and there. I don't expect them to be exactly the same, but it should be very close. Maybe you see the first one was not as close, or we can throw the first one, and you take the average of the 5, and you give me the Q1. Okay? There's one question, the last question there, okay? Anybody has a problem with this? Great, wonderful, that's very easy on me. Okay, the question is, last question, do people have a problem with it? Sometimes, sometimes not. Depends on how things start. Let me see. Okay. By the way, the next week is not buffer, by the way, okay? It's not a buffer, even though the book, sure look at the table. What will be the next week? February 9, March 12, will be Ka over weak acid. Look at your table. Okay. After you get your table here, you have K1, K2, K3, K4, K5. I show you how to determine K1, and you find it. You find the K average, and they want you to use the K average here for the test tube number 3 and find your absorbance if it will match the. So you have to set up equation like this. So K equilibrium average equal test tube number 3, so there will be X here, and this will be 1.00 times 10 to the power minus 3. You have to set up minus X, and this is test tube number 3 will be 6, right? 6.0 times 10 to the minus 4 minus X. Right? This is the test tube number 4. You have 6. Look at you've done the date. Test tube number 3 should be 6 times 10 minus 4 minus X. Okay. Guys, this is the equation you need. This is your solution to this last question. Set up the equation like this. This is your value, this is your value. The K equilibrium, after you find the K equilibrium average, after you find the K equilibrium average, you put that value here. Say it was 127. So the 127. And then you have simplified this equation here mathematically. This is very elementary algebra. So simplify this equation, and you will come up with the quadratic equation: ax plus bx squared plus c equals 0. You're going to convert this to this format. Okay? And then use the quadratic equation solution that x equals plus or minus square root, and you have it in your book. And find the value of x at that concentration. Find the value of x in that concentration. Okay? We got it?
Yeah.
Then we go back to this table here, to our linear graph here, which is y here equal this, and substitute x we came up with from here, and find what's the absorbance, and compare it to the one you measured. Is this clear?
Yes. Okay.
You can go home. Sure. If I haven't signed your book, then